So, welcome you to this course on inference 2. So, the course number is MTH515A, and I will be your instructor in charge. My name is Neeraj Misra. I can be contacted through my email ID neeraj@iitk.ac.in. I also have an intercom number which is 7087. So, in case of any difficulty, feel free to contact me. Now, this is a second course on the inference. You have already done inference 1. So, this is a follow-up of inference 1. So, before I talk in detail about this course, let us try to revisit what are the statistical inference problems. So, let us try to see what are the statistical inference problems. So, a typical problem of statistical inference is that you have a big population. So, let us say P star is a big population. This could be, for example, population of all Indian males. Population of all Indian males. And what your goal is, you are interested in getting information about some numerical characteristic of this population. For example, one may be interested in knowing what is the mean height of Indian males. Another example could be one may be interested in testing the validity of a statement about mean height. For example, one may make a claim that mean height of Indian males is more than 5 feet 4 inches. Now, in that case, I am left with the problem of testing whether such a statement is correct or not correct. Now, the ideal situation would have been if this that I enumerate height of each and every individual of Indian population. I take the mean height, that gives me the exact mean height of Indian males, and then I can estimate it by whatever mean I get, or I can test the validity of a given statement based on the whatever estimate I get, and there will be no error because that is based on the whole population. Now, in statistics, the usual problem is you are not able to get information on each and every individual of this population because the population is too big. So, it may not be either economically or practically possible to take observations on each and every individual of the population. So, what you do is you take information on a part of this population. So, what you do is you take information on a part of population. Now, note that different individuals have different heights in the population of Indian males. So, this height is a variable. Now, when you are randomly picking a person from this population, the height which you are getting is a random quantity. So, what you have in that sense is if I denote x, as the typical height of a typical male chosen at random. Because if you want a true representative of the population, you should try to choose the individual at random and then measure its height. So, then in that sense it is a random variable. Every time you pick up a individual, you measure his height, that keeps on varying and it is random. So, and that is the reason why it is a random variable. Now, certainly if it is a random variable, if it will have a certain distribution associated with it. So, suppose this random variable has a distribution function f, which is unknown. So, what does fx gives? Distribution function at the point x is nothing but probability that capital X takes value less than or equal to small x, and this is defined for any x belonging to R. So, of course, if you know the f, you know the mean. Since you do not know the f, the mean is unknown to you. So, mu of f is the mean, which is nothing but minus infinity to infinity x dfx. So, basically I am writing out dfx. Those who are not familiar with the measure theoretic notations, in the discrete case what it means is summation x times fx in the discrete case, and this would be minus infinity to infinity, minus infinity to infinity x fx dx in the continuous case, or if you want to call it more precisely, it is absolutely continuous case. So, I am you can call this as mu f df. So, I am interested in making getting some information about mu of f. So, what do you do? As I said, the best thing would have been that I measure height of each and every male in the Indian population. I get the exact mean height, and then I have a full information about the mean. I can tell whatever I observe as a mean of all the Indian males, I take that as the mean height and there is no error. I can test the statement, whether a given statement is valid or not valid, based on all the observations which I have gotten from the population. As I said in the beginning, that it is not possible to get observations on each and every individual. So, what do? You take a random sample. So, x1, x2, xn is a sample from, let me say, f, which is unknown. This is a distribution function. And this distribution function contains all the information about the random behavior of x. So, basically these x1, x2, xn are nothing but, in certain sense, n copies of x, which is nothing but a typical random variable or generic random variable denoting the height of a typical individual in the population. So, I have a random sample or a sample. Now, goal is, now this sample only contains a partial information about P star, about the population, because you have taken or you have measured height of only selected individuals. You have not measured the height of each and every individual in the population. So, based on partial information x1, x2, xn, so goal is, based on the partial information which is contained in x1, x2, xn, I have to infer or get information about mu of f. Now, this could be, as I said, this could be getting an estimate of a mu of f. It could be testing the validity of a given statement about a mu of f. So, statistical inference problem, so that's a typical statistical inference problem. So, statistical inference problems are broadly classified into two categories. One is called the estimation and one is called the testing of hypothesis. So, statistical inference problems as I said can be broadly classified into two items. One kind of problems are called estimation. The second one is called the hypothesis testing. So, what you do in estimation is based on the partial information x1, x2, xn, we want to estimate mu of f, which is the unknown characteristic about the population. For example, mu of f could be the mean of f, which is unknown to us. What do you do in the hypothesis testing problem? In hypothesis testing problem, you are given a statement, a hypothesis, and you are interested in testing whether the given hypothesis or the statement about mu of f is correct or not. So, interested. So, based on x1, x2, xn, we want to test the validity of a given statement about mu of f. Now, in statistics, we also call this statement as the hypothesis. So, we are interested in testing whether a given hypothesis is true or not. So, you were exposed to some of these statistical inference problems in your first course, which was MTH 418A on inference 1. So, you did some of estimation over there, but before going to the estimation, you did over something about sufficiency, completeness, minimal sufficient statistics, and so on. The purpose of studying sufficiency, minimal sufficiency, completeness, and related topics was that once you have a data x1, x2, xn, the first job which a statistician or experimenter is faced with is to reduce this data without losing the information. Because this sample may be too large, especially in these days when you talk about big data, this x1, x2, xn may be too huge. And one may be keen in somehow reducing this data x1, x2, xn, but without compromising the information contained in x1, x2, xn. And that is what basically led to the concept of a sufficient statistic. Then he talked about minimal sufficiency and so on. In last course, you also studied about different methods of estimation, like unbiased estimation, uniformly minimum variance unbiased estimation, method of movement estimator, maximum likelihood estimators, and so on. Then you studied properties of these estimators. You also touched upon hypothesis testing, where you talked about that in any hypothesis testing problem, there could be two kinds of errors, type 1 error, type 2 error. And since you cannot minimize the two kinds of errors simultaneously, you resolve that what I'll do is I'll try to fix one kind of error and then try to minimize the second kind of error. So I say that the error which is more serious, I call that as a type 1 error. I fix it at a given level alpha, that it should not exceed more than 0.05, let us say. And then among all the statistical testing procedures, I am trying to looking for a procedure which minimizes the type 2 error. So that you did in the hypothesis testing problem. Now we'll, in this course, we'll further study some of more techniques of estimation and hypothesis testing. Now statistical inference problem are further classified into two parts.